Hi everyone, welcome to the session talking about a very important aspect of technology related to IoT, Internet of Things. Fog or edge computing is a new solution actually to an existing problem with Internet of Things. I'm going to explain a lot of information about that today. The whole key about IoT is actually it is one of those technologies that change in the world. And before I can dive into many of the aspects of edge or fog computing, let me introduce myself for a second. Here you can see that I have done a lot of research about Internet of Things, blockchain and artificial intelligence. The whole thing about the relationship between the hot technologies like Internet of Things and blockchain and AI, and at the same time, the cybersecurity can be explained with the following slides. My favorite slide, which is the slide talking about the whole relationship connecting the four hot technologies. I wrote two books about Internet of Things and its relationship to blockchain and AI. One of them is already in the market, Secure and Smart Internet of Things, IoT using blockchain and artificial intelligence, and one which is coming in August this year, which is specifically for blockchain technologies and application. If you look at this slide, it's going to give you an idea why we are focusing on how to make IoT as a very as a very important technology these days, make it works with the other hot trends. Many of my students will be asking me questions about where should I go when it comes to technologies, and I give them something called IBAC. And this kind of abbreviation, it's helping them to focus on which technology or technologies they should be looking at. The first one is Internet of Things, the second one B for the blockchain, and the third one artificial intelligence with an A, and the C is cybersecurity. And they are really interrelated. Internet of Things need blockchain, needs artificial intelligence, needs cybersecurity, and they're helping shaping the future of technology, especially in hot areas like the Silicon Valley. The next slide will make it much easier for you to explain the four component of IBAC to anybody who is not in the industry. This is one simple way you can show people that what does it mean when you're talking about the IBAC technologies. Internet of Things or IoT fields, blockchain remembers, AI thinks, and cybersecurity protects. And if you keep this in mind, it's going to be very clear to you why we are focusing on making Internet of Things or IoT more robust, more and more open, and add more of the companies and more of the product to Internet of Things. For the Internet of Things, I've always been asked that question. Can you just give me an example to explain what is the Internet of Things to somebody who does not have any technical background? Because we're talking about customers. By the end of the day, the main focus of IoT in the United States is actually the consumers more than anything else. It's not compared to Europe, where the main focus is the industrial Internet of Things, which deals with factories, smart cities, the big scale, the macro level. While here in the United States, we are focusing more on the consumers. You wake up in the morning, you look at your mirror, and it's a smart mirror. That smart mirror will tell you, you look horrible today. I already, have an appointment with the doctor for you at 10 o'clock, and I have contacted Uber or Lyft to come and pick you up. I moved your meetings for today to next week. Take you to the doctor check everything, and then they take you back home. And then the doctor will send that message to the pharmacy. A drone will bring that medication to you, and they scan your eyes or have some identification to give you that medication. That orange container you are using is a smart one, and that one will, the minute you take a pill out of it, a message sent to the doctor on some kind of a graphical design or graphical user interface where, say, he or she took that pill. Once you swallow that one, another message will be sent saying that he or she swallowed this one, so we can avoid any kind of overdose and any misuse of the medication. So this is a very simple example of Internet of Things. As good as it is, to see something like this, and if you've been in the Consumer Electronics Show in Las Vegas this year, in January, you're going to see so many applications beside the smart mirror, beside the smart cars applications, which is something we'll talk about it when we explain the edge computing or fog computer. Smart beds that when everybody at bed, their beds, the lights in the house will turn off because there is a sense that everybody is there. Many applications, but that comes with a price. But it comes with some kind of a load, which is information. There's huge information sent and received by the devices of the of IoT, and IoT as a system has 4 parts. The first one is the sensors, which is something that's very visible to everybody. Everybody see it. A lot of startups dealing with that. The second one is the network. What kind of communication you have between the, taking the information from the sensors and send it to the cloud. And that could be Bluetooth, could be Wi-Fi, could be any kind of some of the protocols now used for the IoT. And the third one is the cloud, all the processing. And then that's where you do all these kind of processing to the information then inside. And the fourth one is the application. So this is, if you look at all these stages, you see that it's very important for us to understand how can we smooth this process? How can we use some kind of a new technology that will solve this problem? So it is actually a hot trend. Even though it's been here for years, it's still, there is some issues with that one. So deals with all component that we consider as part of the 3.0, the Web 3.0, big data, analytic, cloud computing, mobile computer. And now you can add the 3 technologies I mentioned there, which is the blockchain and the artificial intelligence, which is not new, but now it's a kind of hot. Why? Because of the tools and because of the skills and because of the processing power we added to the artificial intelligence. And all of this one is under the umbrella of the cyber security. So the challenge, the IoT promised to bring connectivity to, almost every, aspect of our life. Chairs will go back to their original positions after you leave. I don't have to worry about, my house. Why? Because they sense what's going on. If nobody's home, they're going to turn off the light. It's going to close the doors. I look at the famous cartoons about we're missing milk. The fridge will email you, will text you, will send you a signal saying that milk can expire in 3 days. You don't have enough milk. And there is an interesting application that I want to share it with you here, which shows you how deep it's going to go and how interesting that the Internet of Things will touch every aspect of our life. In the future, we could see something like, a smart a fork that you use for eating, that will be smart. So if you are hitting the food in the wrong way, the fork will say, no, this is not the way you eat. You have to tilt it right and left. And also the fork will analyze the food, and based on your health insurance, they're going to tell you this is not healthy for you. Don't take it. Or it's okay, you can take that part. Same thing goes with having an IP address for every single part of your body, your heart, your liver, your pancreas, all parts of your body will have this kind of an IP address. So the doctor, all what he or she can do, just hack into your, in your body and check it, and get all the information and save you time and save you, all the trouble of going to the doctor, because they have everything, all the signal is sent to you from each and important part of your body. So this is just an example of what kind of future we're expecting with Internet of Things. And I'm keep talking about it, that way, because I want to make everybody to understand that IoT is here to stay. IoT here is to help us. But there is a price tag, and the price tag is not just the money. The price tag of the data itself, and the volume and the velocity of the data that's sent by the devices. The first component of IoT, the sensors. How are we going to deal with that? So as you see on the slide, it's talking the challenge. It's promised to bring everything, every home, every vehicle, every workplace with smart internet connection. But as dependence, on this new technologies and connected devices increase, and the benefit, the use of maturing, and it's really maturing now, the reliability of the gateways that make the IoT a functional reality must increase. Which in another word is, how can they handle the data? How can they deal with the data? We're going to have delays because now you're sending tremendous information to the gateways. Remember, that's the second component of Internet of Things, the connectivity itself. Tesla as a company, Tesla as a car is actually a computer on wheels, and it's just keep feeding information back, to Tesla with all these kind of data. Now we have 400,000 Tesla cars on the roads as we speak. Now, can you imagine, if we have, 10 million of them, or not only Tesla, other electrical cars that send all the information back to the factories? How can we handle that? How can we deal with this huge wave of data? And we don't want to lose data, because data is the new oil, data is new gold, data is the sunlight, as Google said. All of these things are very important for us to capture this data and improve the performance of the devices, whether it's a car, it's a fork, it's a smart ATM, smart street light, and so on. I'll have an example about one of the application of fog computing or edge computing. As every appliance, light, door, piece of clothes, and this is another thing, that you have a smart, shoes, a smart jacket that will change the size and monitor your, your vital signals if there's something wrong. I mean, it's like what you have with Apple Watch that will watch your heartbeat, and if you are really going higher, they're going to ask you to slow down and relax. So this is just a small example about how IoT will enter every single, turn of our life. Coffee become potential internet enables. The Internet of Things is applied to major stress to the current system, because the current system we have here was not actually created for something like this. But next year, according to Gartner, is about 26 billion devices connected by 2020. And when you say a device, everything that has or have an IP address. We're not talking about computer. We're talking about cameras. We're talking about door, rings. We're talking about smoke detectors. All of these things that can be connected to the Wi-Fi, that's considered one of those devices. And all of them are just feeding information back, to the source. So if you think about the devices categories, you think about how many of them, and this is a very conservative number, 26 billion is, I heard from other companies that it could hit 50 billion devices connected, giving the speed of introducing new devices and new, appliances, and always adding that term smart. When you add smart, you're adding an IP address and you're adding a program, which is to the device that will define it as a smart device. The current system, which is the popular one, is a centralized cloud data processing in a single site, resulting in lower costs, a strong application security, but with the volume of the data, of input data that we receive globally from every place, now this centralized process requires some kind of backup, some kind of help. And this drives us to a very important, aspect of fog computer and edge computing. All the enterprise data is pushed up to the cloud, even if the action is actually happening few feet from where you need that decision to be taken. Is made and taken action, but the system is inefficient. It goes through a well-defined process where sensor, communication, cloud, and then you send the insight or the actions. To make it efficient, there is need to process some of the data at the local level, in case, in a smart way. And I always compare the case of edge computing or fog computer and the cloud to the case of the local government, like the state, which is the fog and the edge, and the federal government, which is the cloud computing. I don't have to do everything at the federal level. There's a lot of decisions can be made at the local level, and that will free some time, or some of the time, for the federal level to deal with bigger problems. And this is how you can see how we are helping, freeing some of the resources at the cloud level, so we can deal with the, with the decision that can be made at the state level. The need for smart processing, and again, the smart itself is one way for us to avoid all these kind of a data bottleneck that we deal with it when it comes to sending everything to the federal side or to the to the cloud. IDC estimated that, and this is an important statistic, estimates that the amount of data analyzed on the devices that are physically close to the Internet of Things is about 40%. So if you can take 40% of the data and process it and make a decision at that level without going to the cloud level, you are freeing 40% of the time for the cloud computing, so it can do more intensive, more important tasks, which support the urgent need for different approach to this need. Now, to deal with the challenge, this is what we have. We have the fog edge computing. You can name it whatever you name it here. I'm going to go with fog and computing is the champion, and edge computing is the same thing. And there are reasons for calling it fog and edge. The edge is the physical proximity of where you have the devices, where you can deal with them at the edge. The fog computing is coming from the cloud. When the cloud computing is high, the fog is close to the ground, so close to the action. So fog computing allows computing, decision-making, and action-taking to happen through the IoT devices and only pushes relevant data to the cloud. So that will help having this kind of solution here. And it makes sense. It makes sense that, IoT needs this kind of help, because if you think about it, in order for me to expand the sensors and have sensor everywhere, and now think about it, we have 5G coming, and we have some kind of implementation of 5G. And if we don't have this kind of infrastructure that will help us receive that huge data coming from the 5G points, we're going to find ourselves really dealing with huge latency, delay, and we might find ourselves have some breaking points at certain parts of the IoT infrastructure. So the data center, which is the cloud, the fog, or the edge, and the device. That's a simple diagram to show you where the fog will be in the process. You have the sensors, you have the decision made at the edge computing, and then whatever information needed to be sent in the cloud will be sent. It's not going to be sent in the raw data. It's going to send in, okay, this is what we found. We just send you that information. Intel is actually a huge leader in the edge computing. I have friends working at their lab in near Sacramento in the edge computer, and it's really doing a marvelous job when it comes to edge computing. Cisco is another name you can mention in that field. Is actually the one who coined the term fog computing and gave a brilliant definition for that. The fog extends the cloud closer to the thing that produce and act on IoT data. These devices called fog nodes, edge nodes, can be deployed anywhere with network connections. So this is how you're going to look at it from that perspective. This is how it's going to help you understand it. On a factory floor, here's some of the real application. On the top of the power pole, alongside the railway track, in a vehicle, on an oil rig. Any devices with computing storage and network connectivity can be an edge or a fog node. So this is how we define it: computing, storage, and network connectivity. So it can be part of the network of the fog or the edge node network. Examples include industrial controllers, switches, routers, embedded servers, and video surveillance, cameras. All of these things are considered as part of the edge or, computing nodes. They have their computing power, they have their storage, and they have their connectivity. They have their IP address to be part of the network. And the response time, and this is very quick look at it. If you talk about the fog or the edge nodes closer to the IoT devices, milliseconds. Aggregated, let's go second to minutes. And if you just go straight, and I'm talking about the first line, the response time, the cloud itself is going to take minutes and days and sometimes weeks to make that decision. We can't do that. And especially with some of the application which is mission critical, not only for the business, for your life. I mean, if you think about cars like Tesla, and you need to make that decision in a fraction of seconds, there's no room for wait. There's no way for you to wait until you download that decision, a minute or two. You are going high speed, and that decision will impact your life. Same thing with the healthcare. Same thing with so many of the applications that will impact human. Application example, you're talking machine-to-machine communications, telemedicine, training, and if you aggregate this when you have visualization and simple analysis, And for the cloud, it's the big data. How long IoT data is stored, transient. You don't have to store it. You just, on the fog or the edge nodes, just have them, as long as you need them to process the data. And then the geographics, very local. For example, one city block, you can have all these devices where they're part of the edge. You can have them in a certain poles. You can have them in a nice structure where it doesn't really have this kind of environmental pollution, and you aggregate that one in multiple blocks. For the cloud, it's global. So this is just giving you some sense of the network edge and how the fog nodes is really established and why we should go with that. To understand the fog and edge computing concept, the following action define them. Analyze the most time-sensitive data at the network edge, close to where it's generated or close to where the action, and send, instead of sending all this vast amount of the data, sending everything to the federal government, let them deal with it, and the state level does nothing. Acts on IoT data in millisecond instead of minutes, hours, days when it comes to the cloud. Send selected data to the cloud for historical analysis and long-term storage. After we finish that one, we can send this information to the cloud, and this information will be used to create some models, insights. And again, I'd like to remind you about the 4 components of the IoT ecosystem. You have the sensors, you have the network, you have the cloud, and you have the applications. So when we talk about how can we really streamline the information and the data here, and how can we really have a model that will help each part of the IoT, that's going to make it faster to process more data and to have a better model that will create a better applications for the consumer user or for the industrial user. The benefits of using fog or edge computing is minimize latency. This is number 1. Conserve the network bandwidth, extremely important. And it means you can send more and more information, more and more important information. Address security concern at all the level of the network, because you know exactly you can secure each one of the of the nodes. Operate reliably with a quick decision. So it's a reliable way. It's a quick decision at the level of the of the nodes, of the local nodes. Collect and secure wide range of data. Move data to the best place for processing based on some kind of algorithm, based on some kind of a model you have. Lower the expenses for using high computing power. Instead of using the cloud, you are using all these small components or small devices that can process the data, and you're reserving and preserving the processing power of the cloud for bigger tasks and needed and less bandwidth, and better analysis and insight of the local data, because you're close to the action. You can define that. You can make a decision which is based on parameters within that area. Keep in mind that edge or fog computing is not a replacement. It's not a replacement of the cloud computer by any means. That part is very important to keep in mind, because we're going to have all the local government, the state government. We don't need the federal government. You can't do that. You need both, because if you just dump everything on the fog computer, you're creating a cloud again, and we are back to the same problem. It works in conjunction with the cloud computing, optimizing the resources and help a lot of make smooth, streaming of the process of data and receiving the insight and storing and archiving and creating models. It's a need, to address 2 challenges. That's the whole idea of the fog or the edge computer. Real-time processing and action of incoming data, limitation of resources like bandwidth and computing power. And fog computing is not the sensors. And there's a lot of times you're going to find some people who look at it, well, okay, no, it's not. The sensor is just a feeder to the device itself. And if you look at some of the hardware available for fog computing or edge computing, you're going to see that they're similar to any kind of, networking devices, a rack with all the devices there with the routers, but it is scaled down version of looking at, a data center where you have huge farms of all the devices here. So we're dealing with real-time process and action of incoming data and limitation of resources. For example, the bandwidth and the computing power. Another factor that helped the edge or the fog computer, the fact that it take advantage of distributed nature of today, virtualized resources. and it can be everywhere. You have sensors, you can aggregate the sensors to a certain edge compute and process this information, and you can design the software, design the interface, design the model specifically for that. If I'm dealing with oil rigs everywhere, so I know exactly what I'm doing. I know what kind of data I'm expecting for this one. The same thing if I'm talking about traffic. The same thing we're talking about, telemedicine, or talking about, education. So I can have a model and customize whatever I have in that device according to the expected data coming from the sensors. And that's make it more intelligent because you're really optimizing your models to that application. And we don't have this on the cloud. The cloud will accept everything and anything, and they have to deal with it, categorize that one, and then make that decision. This improvement to the data path hierarchy is enabled by increased computing functionality. Manufacturers are building into their edge routers and switches. So they are moving some of the capabilities of the cloud to those small, equipment or boxes or racks that define the edge computing nodes. So here's a real life example that will make it much easier for us to understand. Traffic light system in a major city is equipped with smart sensors. So that's the first component of the IoT. Now the local team won the championship of a game. And it is the morning of that parade. A surge in traffic into the city expected, celebrations, and everybody is coming there to celebrate their team. Traffic bills, data are collected from individual traffic lights. The application developed by the city to adjust the light pattern and timing is running on each edge device. So we know that the team and the parade and the fans and celebration, everybody will go in through that route. So we have to reconfigure all the traffic lights and intersections accordingly, that this is going to be closed, this is going to be closed, this is going to be open. The app automatically makes adjustment to light patterns in real time, which means that this is the case. It's not closed from 9 to 9 and nothing. As when we go close to the end and we have less people, in that area, you don't have to wait until the last person is gone. You can just switch back to normal because now there's no traffic. And how many times you actually, in the middle of the night, you're driving back home, or you're going somewhere, and then you are there in that, intersection, and it's red for you, and nobody's there. And you say, what kind? And you're waiting as if it is really a rush hour. And it's few seconds, I understand, it's 1 or 2 minutes, but it still is building up. We're talking about utilizing. So if you have 1 minute here, 1 minute here, 2 minutes here, 3 minutes here, it's going to make it much easier for the traffic to go smoothly, especially at times where you need every single intersection, you need every single light to be smart. So the app automatically make adjustment to light pattern, time, the edge, working around the traffic information as they arise and diminish. The traffic delays are kept at minimum. Fans spend less time in their cars and have more time to enjoy their big day. And if you're a big fan like me for those sport, events, you understand what does that mean. Just waiting, in line to get into the parking lot. After the parade is over, and this is the key thing, this is a very important aspect here, that all the data collected from the traffic light systems would be sent up to the cloud and analyzed. Now, we're not sending all the information as we speak. We are sending this one after fact. Supporting predictive analysis and allowing the city to adjust and improve it for the next one. In the future traffic, events. And it's not just only for the parade, for anything. Anything happen, constructions, change, adding new, public transportations. There is a little value in sending live streaming from everyday traffic because there's nothing changed to the cloud and analysis. The civic engineers have a good handle of the normal traffic because we know exactly how it goes every day. They live in the city, they plan it, they understand it. The relevant data is sensor information that diverges from the norm, such as this data, the data we get from the parade day. That's the one that I need just in case. I mean, today I was coming here to the office and there was an accident 680, and they just closed the whole area because there was some kind of a shooting on the highway in 680, and they shut it down completely. Now you need to know what is the and this time, which is the rush hour in the morning, it's really important to understand how can you smooth this one instead of people waiting for 2 hours, in traffic. How can we inform that one and move them to other areas where we have less people waiting in this accidents? So what is the dynamics of fog or edge computing? Fog is or edge computing thought of as a low to ground. That will be a term used by the C-level or the non-technical people, extension of the cloud to nearby gateways and proficiently provides for the need. So this will be an exciting or interesting term mechanism, low to ground. So Gartner, this is one of their top network analysts. This is what Joe said: the enormous number of devices couples with the sheer volume, velocity, and structure of the IoT data. They create a challenge, particularly in the areas of security, data storage, management servers, and data center network with real-time business processing at stake. So that's some of the whole problem we talk about it and how can you, especially with the security. And that's why, if you remember, I showed you the IBAC, concept, how Internet of Things will needs the blockchain for security and needs the artificial intelligence for processing and needs the cybersecurity for the umbrella for the protections of the data. And if you are in the news, if you are listening to this one, you heard about Facebook, new Libra, cryptocurrency, and based on their blockchain system, blockchain platform they created, and they have a white paper they just released this morning. And it's talking about the security aspect and all these things using blockchain. So and how it's really believes the vast number of user at Facebook. A data center managers will need to deploy more forward-looking capacity management in those areas, enable for them to proactively meet the business priorities associated with IT. And this is a very important mindset dealing with the edge computing. Handling and backhauling issues that shadow the IoT future, edge or fog computer offers a functional solution, a solution that will make it much easier for people to deal with the issue of the fog. And this is why when I'm talking about fog or edge computing, it's very important to understand that IoT needs that one so it can continue to grow and expand, and deployment of many devices, because it's going to be at the point where the cloud will be overloaded, and with all this information coming, and we have the delay and we have the processing errors, it's not going to help. Networking equipment vendors propose such frameworks, and Intel and Cisco and the other companies actually dealing with this. Envision the use of routers with industrial strength reliability running in combination of Open Linux as an example. And you're talking about virtual machines, you're talking about embedded vendor operating systems. By using a platform, application could be ported to the IT infrastructure. So it's easy for you to have it, part of your IT, and using a programming environment that supports multiple vendors. So you are actually platform free. You don't have to be stuck with one vendor. In this way, Smart Edge Gateway can either handle or intelligently redirect the million of the tasks coming from all the sensors, part of the IoT network. They only transmit just the summary and exception of the data to the cloud, so they can improve the model, process the data, and send a decision that will impact the whole sensors network. And this is just a small architects about Internet of Things and fog or edge computing. I'm not going to spend too much time because this is specific for for Cisco, but this is just give you an idea about how it works from embedded system and sensors to edge and multi-service edge computing to the core and the data center with all the protocols needed for such movement. So the fog and the edge computing and smart gateways, and this is where the money is when you talk about smart gateways. The success of fog computing hangs directly on how the reliance of smart gateways directing countless tasks on the internet teaming with IoT devices. So how can you define the reliance? The IoT reliance will be necessity for the business to continue with the IoT operations. The following tasks will ensure this success: redundancy, security, monitoring of data, of power and cooling, failover solution in place to ensure maximum uptime. So this is how the IT will help in this case. And now, according to Gartner, every hour of downtime will cost an organization on average about $300,000. Speed of deployment, and to just add to this, I have no idea how many of you heard about the downtime for Target. Target stores had 2 hours of downtime on Saturday. They have one also on Sunday, and it took like 2 hours. So you can imagine, how much money they lost because their IT infrastructure could not handle that. Maybe they should use edge computing to process the data close to, city by city, instead of sending everything to a centralized location that will end up with, if it's down, everybody's down. Single point of failure. This is what you are trying to avoid. Speed of deployment, cost-effective scalability, and the ease of management with limited resources are also concerns. Actually, big concern for that. So what's the conclusion for that? Moving the intelligent processing of data to the edge only raise the stake for maintaining the availability of these smart gateways and their communication path to the cloud. When IoT provides ways and means that allow people to manage their daily lives, from locking the doors, checking their schedule, checking their heartbeats, all these kind of things, cooking their meals, eating, gateway downtime in the fog computing become a crucial issue. And we talk about this, about the case of smart gateways, how it really will be at the heart of the edge computing. Resilience and failover solution that safeguard those processes will become more and more essential. That's another area where you see the market will be looking for when it comes to, to the edge computer. Okay. So I'm done with my presentation. So let me see. I think, if you give me a second, I'm going to go to the questions. Okay. Yes. Perfect. Okay. Let me just give me a second here, and I'm trying to log into the other. Okay. So I'm ready for the questions. If somebody wants to ask a question, I need to have my contact information here. Can you give me a second? Okay, so I have full screen. Yes, okay. So any questions? Anybody has any questions? If not, then thank you. Okay, can they hear me now? Okay, what about the crowd? If they have any questions, they can just, use one of the 3 contacts here. They're welcome to use that. If not, then we're done for today.